Hey YouTube, Jay Kilroy here. It's hot. AC's not working. Smell like a stuck pig. Anyway, if you remember recently, I had a video on doing some work on a Powermatic lathe, a Powermatic wood lathe, a Model 90, for a friend of mine. And the Powermatic has a 1 1/8 inch tool rest shank in its cross slide. I don't know if you're familiar with wood lathes, but there's a quick acting cross slide where you just loosen a clamp, slide it, tighten it down. It has a 1 1/8 shank. The customer originally brought it to me and said, hey, I got this 1-inch shank tool, which I've since learned is from a Delta, and I would like to make a sleeve for this to upsize it to 1 1/8 inch. Well, as customers are wont to do, he changed his mind. The man fancies a bit of bowl turning, and you know, everybody goes to the flea markets and sees these turned wood bowls and sees these exorbitant prices on them and thinks, oh, this guy's just making a ton of dough. Well, they've never turned a bowl before, have they? Anyway, looking, while he's contemplating his future as a bowl turner, he finds that there are tons of these custom rests, these custom tool rests, these bows and them all nicely shaped for making bowls, so you can turn across the face of a bowl. I hate wood turning. Just because I don't like, I mean, I wear glasses. I think people that don't wear glasses probably like it a little more, because if you wear glasses or contacts and you're wood turning, you've got to wear like Magnum face protection. It's just hot and sweaty and the stuff's flying everywhere and it gets stuck all over you. And I'd rather have a hot chip land on me and make me do the canasta than have wood chips in every square inch of my body. Anyway, all of these custom bowl turning rests, guess what? They have 1-inch shanks. Matter of fact, if you go out and look around, 1 1/8 inch shank's pretty darn rare. So plan B. Plan B is he wants me to turn this down to 1 inch, and then he wants to permanently retrofit his cross slide to hold 1-inch tools. So I've got the cross slide set up over here in the mill. We're going to start the process. So let's take the machine on over and do that. By the way, if in the middle of the video it all goes dark, it's because we got a serious front coming through and I could lose power at any moment. So anyway, let's go check out the cross slide and investigate this project a little further. Alrighty, here's the cross slide in the vise. It's sitting on a couple of 1, 2, 3 blocks down here because I didn't disassemble it entirely. I did take the clamping handle off of this side because it was just going to be flapping around. This little split pin holds it in place. There's a rather banged up bronze bushing here. I don't know if that's original or not. I'm going to go back and look at the schematics that are available on Keith Rucker's fine vintage machinery website. So this hole here is 1 1/8 inch. He wants to be able to take 1-inch tools. The idea of doing a 16-inch wall bushing seems extremely short-lived. Here's the clamping arrangement that comes through here, the split cotter. Very nice arrangement. except there's no key or anything to maintain it in the center. You can just bump it and, you know, kind of bump the whole operation out the other side, but it works fine. So there isn't, if you look at this right here, there isn't a great deal of material here to work with. That's pretty small gap right here, right? So as is typical, what we're going to do in order to make this hole smaller is, first thing we're going to do is we're going to make this hole bigger. So we're going to bore this hole out. Right now I'm thinking 1/8 of an inch total. So that'll allow me to make 1/8 of an inch thick bushing to press down into this hole solid. Then we will rebore this hole to size to fit our split cotter. And these don't really fit real well. I don't know if you can see the mating surface there. You see that the radius of the split cotter here is much larger than even the 1 1/8 inch tool. So they just kind of grab along this small section right here. So we're going to see if these will work. If these won't work, we'll end up making some new inserts for this arrangement and leaving this stock arrangement. This is a nice arrangement. So what I've done right here is I've got the got a coaxial indicator here. This is actually a Schar's version. It works quite well. I've also got a Blake. If you can't or don't want to dump the change on a Blake, which I mean I think they run around $200 new, and you want to use a coax, this thing works fine. It comes with a wide variety of tips. I believe I actually got this one as a gift, but it comes with a nice wide variety of long tips, both straight and curved, and it works really well. I can't complain about it at all. Is the fit and finish of the tool as nice as the Blake? No, but it's, you know, not even half the price of the Blake. So if you look it up, so this works out well. I've already done the centering job, but just to show you about as good as we can get here. Each division here is 5/10. Yeah. And so I'll take that. That's plenty good for this arrangement right here. So I'm gonna go ahead and get the tool out. We're gonna go ahead and set up a boring head, and we're gonna take 1/8 of an inch out of this casting here. Oh, told you there was some rain coming through here. It's out front of the shop. My intersection here is the intersection of 3 hills. They all come down to this intersection here, and then proceeds on down to the river, which is down here. That's it didn't start raining but maybe 5 minutes ago. All right. I didn't have a boring bar small enough and long enough to do the required 2 3/4 inches that we need for the longest shank on this tool. So that's how far down we have to go here. So what I did was I got a 1 1/4 long rougher that's honestly much more comfortable over in the Kearney Trucker, but I already have this set up, so we're going to do it over here. This is the largest end mill holder that I have for this machine. This is certainly the largest end mill that I would regularly use on an R8 taper. So even then, not regularly. So we're just going to go ahead and plunge on in and straighten this bore out here all the way down. it's going there. There's the cut right there. Speed up a little bit. I'm going to clean this out a little bit here. So what I did is I went and added a piece of tape here. This is my depth of cut, 2 3/4 inches roughly. Not a real, I just need to be beyond 2.75, which is the length of this longest shank. So let's get back to cutting here. I've cut through most of this recessed area. It was making it kind of rough going. So I've got through most of the recessed area down here, and it should hopefully help things out a little bit. Probably need to clean the chips out of the bottom of this thing. Let me get my compressed air going here. Alright, we got us a piece of a Victim here. We're going to face off, center drill, and get a center in this baby. Alright, ready to go. Alright, face it off. A little center in this thing. So we're going to carve we're going to do the ID first, because that's going to be the most significant amount of material removal and the highest cutting forces. So we're going to go ahead and we're going to drill this thing out to 3 inches and deep, and then we're going to we're just going to put a 1-inch drill in there and knock it all the way back. That'll pretty much finish up our ID. And then we're going to carve this back. Total distance up to the face will be 2 3/4. Well, we're going to add 1/8 of an inch to it, so we'll say 2 7/8 all the way back. And then we'll part off, and we'll have our finished, not our finished bushing, but at least a good start. We got a 1-inch Morse taper 3 drill here. Alright, we got us a 1-inch drill. We're drilling into steel here. We're going to start off about 85 service feet per minute. That's around 300 to 325 RPM. So we're going to kick into our first back gear range. Speed it up significantly. All right, let me check that depth out just to make sure that we're where we think we are. Excellent. All right, let me clean this mound of chips up here. You know, you got a nice drill, cutting a nice full width chip there. That's actually the first time that drill's ever touched metal in anger, so I kind of expected a decent performance there. Let me get set up to let this cool down just a little bit, and then let me get set up to start doing the OD work here. All right, so our 1-inch bore is done through here. This has had a chance to cool off. We need to trim this 1 5/8 diameter back to 1.5. Get it back in open belt here. I'm going to slow it down first. That's the wrong way. All right, 1.621. Let's take off. I'm going to go at it with 50 thou. got 73 more to go. I'm just going to go ahead and slow the speed down a little bit. And dial in that 70. There. About 1,000 RPM. Those chips are hot, baby. Alright, 1505, I can live with that. This is the diameter of the flange that's going to sit on top. So now we're going to take this down to the 1 1/4 diameter that's required to go through the hole. So we got a 1/4 inch to come off here. And there's 80 thou coming off. About to make a mark. Alright, that'll give me something to work with. Hot tamale. Start doing easy math and start taking off 100. Here we go. 100 thou. Okay, that's fun and all, but those chips are hot. Alright, we got about 72 thou left to come off. Our wall thickness is starting to come on down here, so I don't want to hammer it like I've been doing. So I'm going to start taking smaller cuts. I'm going to go 40 thou on this cut. Alright, now we're going to go 30 thou on this cut. That's a nice depth of cut there. Chips are coming off very cleanly and depositing in the bed, not flying all over the place, so that's a plus. Let's check the measurement. All right. Okay, I'm 1 thou over my number, so we're getting close to checking. Let me go over to the mill and check my number over there. So I'm glad I checked, because my hole bored by that 1 1/4 end mill is about 4 thou oversized. So we have achieved a finished dimension. So let me get some cleaning some of this off of here so I can get a parting tool in here and slow this baby down, and we can part this piece off. Alright, we're set up here. My parting tool. Off camera, I took the tape out of that face, so somebody was going to point that out. And now we're just going to go ahead and I verified my depth, and we're just going to go ahead and part off. Shouldn't have very far to go. I'm going to stick a little drill in the tailstock to catch it. Something smaller than 1 inch. Alright, there you go. So let's get her going here. We're in back gear, running about 100 RPM. Got about 300 thou to go, I guess, total. There we go. There's the start of our bushing there. Need to chuck up and clean this off. Alright. There's our bushing slipping down into place there. Now we've added some height here with this flange. I'm going to turn it on, Kilroy. We've added about, what does that work out to? 77 thou, 80 thou, 78 thou, 80 thou, 80 thou. We've added about 80 thou. So I need to take 80 thou off of this surface here so that the tool isn't raised up. I don't know if this is a reference surface of any type, but I want to leave it where I got it. So we're going to skim. I'm going to set up on this, and we're going to skim this off. I'm just going to leave this roughing and milling here and do it with that. So I set my Michitoyo quill readout on the 0 there. Alright, that was nasty. I know I should have put in a shorter end mill, but just call me lazy. Alright, this fits in nice. We're back to our original height here. So we're going to go ahead, what we've got to do is we're going to pin this in. We're going to put this in here. We're going to choose a location, probably back here, and drill through this flange into the casting and pin this in with a split pin, and then we're going to rebore this hole here to open everything back up for our split cotters. So let's get set up to pin this in. Okay guys, we got our bushing made. We've got our hole bored. We've got the flat top of the tool rest planed off. We've got our bushing made. We've got our bushing in place. Now what we're going to do is we're going to drill for a pin, anti-rotation device really. What I'm going to do is I'm going to drill a hole right where, basically on the halfway in between the OD of the bushing and the ID of the hole, kind of like the I guess they call it the Dutch key that we did with the Kearney Trekker crank series, Getting Cranky. In this case, it won't be a big old pin with a tight fit. It's just going to be a little bitty 3/32 split pin, and I only really want it there to keep the bushing from rotating. So it needs to hold the bushing in the rest and keep it from rotating so that the split cotters will line up properly with the hole. And the reason I don't want to put it in permanently, like I don't want to weld it, I don't want to Loctite it in, is because if it becomes necessary to make a new bushing, this bushing is not hard, right? If it becomes necessary to make a new bushing because this one wears out through extensive use, I don't want to have a big problem getting this one out. I'd like for it just to, you know, slide it out and make a new one. Matter of fact, I could probably take some dimensions on this one and just send him one. But I don't want to make it a permanent addition. I thought about welding it or brazing it or Loctiting it in place, but I have rejected those solutions. So let's go drill this little pinhole, get the pin in place, and then we're gonna start working on the split cotters. All right, guys, gals, friends, we're going to now that this has been flattened off here and our bushing fits in nicely, we're back to our original height. We're going to put in a split pin, spring pin it's called. I call them split pins. Most vendors, Master, call them spring pins. I call them split pins, but same thing. It's a 3/32 pin. You're wondering to yourself, what in the world is that little thing good for? Well, in double shear, this is good for about 1,100 pounds, if you can believe that or not, right? But I think a lot of people overlook spring pins as useful little devices. What we're going to do is right over here, we're going to drill a hole for this pin. We're going to peg this thing in here, and then that'll hold this in place along with a clamp while we bore this hole here for the split cotters. For a 3/32 pin, the recommended hole diameter, 3/32 is what, 97 thou. The recommended hole diameter is somewhere between 94 and 97 thou. I like to use the number 41 drill, voila, which is 96 thou. It does. What did I say about getting it out of back gear? Come on, get out. All right, there we go. We got to make sure and set this pin down far enough so that it doesn't interact with the rest. The pin is hard spring steel, and the parts are, I don't know if you could hear any of that. We got to make sure that this pin rests completely flush or slightly below the surface of this, because this is hard spring steel and the tool rests are just cast iron parts, and if that little nub of pin was sticking up, it would work its way into that tool rest in no time, and that's just not what we want. So this worked out real well. That pin is right where I wanted it. Nice and clean there. This hole here. So that will keep this from rotating in the hole so that the split cotter portion will line up properly every time. So what we're going to do now is we're going to turn this in the vise, get it resituated in the vise, and we're going to get set up to bore this hole here. Alrighty. So we are in the back in the vise here, and what I did was I placed two 1, 2, 3 blocks vertically against the fixed jaw, and I just slid the flush underside of the cross slide up against the 1, 2, 3 blocks, and then I let the moving jaw come to rest where it may, and we have a very nice sturdy fixture now with the bushing here still in place. We're going to rebore this hole, so I'm going to have to put the Blake or the Blake-alike back in this hole here, and we're going to center up on this hole here.